Welcome to Smart BIM Studio.
Hello engineers, welcome to the new series of Learning Revit API Development by using Parallel Programming Strategy. In this parallel programming strategy, we'll learn both the Revit Dynamo and C# programming. Dynamo will help us to visualize the data flow, scripting strategy, and the logic building. The same script will be translated into a high-level C# programming. In our previous video, we have developed a Dynamo script that read and write the fire rating of a door. In this video, we'll develop a C# programming for the Dynamo script that we developed in our previous video. Since this script was developed from the reference of that Dynamo script, I recommend you to watch that video first and continue with this. Let's jump into it. We start by importing libraries. These are the foundations of any Revit plugin. Attribute let us define how transactions behave, whether it is manual or automatic. DB gives us access to Revit elements, parameters, filters, and transactions. Link allows elegant filtering like Dynamo list.filter by Boolean mask. Without this, we couldn't access the model, filter the elements, or modify the parameters. Next, we define plugin classes and tell Revit how to run it. Namespace keeps our code organized, especially useful in large tools. Transaction means we control when changes are committed. This XML command makes the class executable for Revit add-ins tab. You could use transaction.automatic, but manual gives more control. This is the method Revit calls when plugin runs. It's like a Dynamo run button. Command gives access to the application and document. Messages help us to get written the error message if any. And elements that will be useful when we interact with the Revit interface. This method is where all logic lives, for filtering to updating. We extract the active document and UI context. This is equivalent to Dynamo's document.current node. UI application gives access to the full Revit environment. UI document let us interact with current view and selection. Document, this is the actual model we will modify. This is the starting point for any Revit automation. We define two inputs, the door name we want to find out and the fire rating we expect. We create a category filter to isolate door elements. This is like using the category node in Dynamo. This ensures we only work with the doors, ignore walls, windows, etc. We use a filtered element collector to gather all doors, then filter by name using link. Where passes category, here we will put the category of element we are looking for, where the element is not element type, and here we are using a link to find out its exact match with the name, and we are getting the ID of an element and we are looking for the first element. In Dynamo, this would be all element of category, element.name. We initialize a string to store feedback. This will be shown to the user later. This helps to track what plugins are doing, especially useful for debugging. In Dynamo, This is like a connecting a watch node. Here we retrieve the door element and its type. Fire rating is a type parameter, so we need both. We access the fire rating parameter from the door type. Get parameter fetches a built-in parameter. Door underscore fire underscore rating is a predefined by Revit. In Dynamo, this is element.get parameter value by name. So we check if the parameter exists or has a value. This prevents null error. This ensures we didn't crash the plugin if the parameter was missing. Defensive coding is key to Revit automation. If the given values are okay with the condition, we will just find out the fire rating value from it. We check if the value matches our input. If it does, we confirm it. This avoids unnecessary updates. Clean update is better than overwriting blindly. If the value is missing or incorrect, we start a transaction and update it. Transactions are required for any change in Revit. Set updates the parameter value. Commit the finalized change. In Dynamo, this is element.setParameter by name. If the fire rating doesn't have any value and it doesn't contain any value in it, then it will give a callback message to the user. So let's run it. Let's run the tool. The fire rating value was successfully updated here. Let's check the model. So this we will take ID and verify by that. This is the component. Let's check whether the fire rating was updated or not. Yes, it's successfully updated here. Let's make a few changes here. Instead of 2 hours, I'll update it with 1 hour and make save and hot reload. Just come here, smart tools, and the door 145, ID number 145,999 was updated with 1 hour value. Let's check whether it is updated or not. Yeah, it was updated. Our code was successful. Here in this parallel learning program, the advantage is in the beginning stage we will develop a script by using a visual programming of Dynamo. There we will understand how the data will flow and how it is working. Finally, we turn that same script into a C# programming. This is much easier to identify the logics behind of it. In this series, there is a lot more videos to come. I recommend you to follow the channel and give your valuable feedbacks. And if you want to see any specific automation, let me know in the comments. For more such content, follow Smart BIM Studio. Thank you.